Let's begin. Today's November 14th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 4, 9, 15, 19, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B takes a look at the 3-digit solution, and the Turing machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C takes a look at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card D takes a look at our first 2 digits, triangle and square, adds them up, and compares the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again takes a look at our 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where the 3-digit solution has a pair, as in the example 131, or alternatively, the solution has no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So looking at the criteria cards, I think the first thing I'd like to test is criteria card D. Okay, so the Turing machine does not approve of my choice. Notice that I did pick a 3 for triangle, 1 for square, and its sum is 4. 4 is less than 6, but since the Turing machine does not approve that, it's letting me know that the sum of the first 2 digits is either equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section D. And that again is that triangle plus square should be either equal to 6 or be greater than 6. And unfortunately, I don't think we can actually cross out anything at this point, because you could always have a 1 and a 5 add up to be 6. So, everything between 1 and 5 is still okay. So the next thing, let's go ahead and test criteria card E. Okay, so the Turing machine does approve of my choice in 314. Notice that 314 has no pairs, and the Turing machine approves of that. So we'll say that the solution has no pairs. And because there are no pairs, of course, there are two possibilities, where all the digits are distinct or all the digits are the same. And I think we can exclude the scenario where it's a single digit repeated 3 times, since criteria card C does let us know that there has to be a largest digit among our 3 digits. So it can't be the same digit repeated twice because no digit is bigger than itself. So yeah, we're looking for a solution that has 3 distinct digits. And so again, we still can't cross out anything, but at least we do know, again, the sum has to be equal to 6 or greater than 6. And we're looking for something that does not have any pairs. So let's see. How would criteria card B work? What if there were maybe no 3s? How would that affect our selection? I'm not sure. So obviously, either if there is a 3, it's either there or it's not. But otherwise, we really have no indication of, are we looking for 1 odd, 2 odds, 3 odds? It's hard to tell. So let's go ahead and test criteria card A. Okay, so the Turing Machine does not approve of my choice for square. I did pick a 1. 1 is less than 4, but the Turing Machine does not approve of that. So that means either square is equal to 4 or greater than 4. So let's go ahead and type that up in our notes for section A. And again, square is either equal to, we'll say equal to, well, let's see, how can we say this? Yeah, equal to, we'll say equal to or greater than 4. But really what that means is it's either 4 or 5. So let's go ahead and cross out 1, 2, and 3 for square, leaving us with 4 or 5 for square. Now, does that in any way help inform us a little bit more about criteria card D, the sum of equal or less than 6? Well, the only distinction is triangle cannot be a 1 if square is 4, because that's sum is less than 6. But 1 and 5 again is still in contention. We can't exclude 1 just because of the 4. It does work for 5. And what else? Yeah, I'm not sure if there's much more to pick from or sort of deduce. Well, we did complete our 3 Turing tests for this round. Let's now go into the next phase, which will help us inform ourselves in constructing a good second round proposal. So notice we did not, criteria card A is still outstanding. It could be either a 4 or 5. We did not test criteria card B, letting us know how many 3s there are. We didn't test which one could be the largest. And it is still a bit outstanding, criteria card D, the sum of the first 2 digits. So as far as a sum of 6, the only possibilities now are 2, 4, and 1, 5. And thus far at that point, you could say, yeah, square looks to be the largest. But then how would you pick circle? Besides criteria card C, there really is no sort of direct reference to circle in order to pick it. So how would you choose circle? It could be that it may be the lone 3. There is a 3. Obviously, this 3, triangle 3, for a sum of 6 wouldn't work. So you could say something like that. And then, the sum of 6, triangle will inform us what square is, therefore defaulting what triangle would be, and then it could be that there is a lone 3 and that would be circle. That's plausible. Or it could be, well, there has to be a largest. So again, like I said, as far as between triangle and square, square has to be the largest among those two. So the question is circle going to be larger than square or not? But let's see. Yeah, if that's the case, again, why have the largest? If circle is to be a 3, then I think it would almost be, criteria card C would almost be irrelevant, because why would you even have that? You know square would be the largest. So perhaps maybe there is no 3, and maybe circle is the largest, which would make circle be 5, square be 4, and triangle be 2. So you have 2, 4, 5, sum of 6. There is no 3. So making basically circle not be 4 or anything smaller, forcing it to be a 5. Yeah, perhaps that could be it. And obviously there's a lot of possibilities if the sum of the first two were greater than 6. That's also a possibility. But let's go ahead and do that. Let's do 2, 4, 5. Let's see if that's helpful. 2, 4, 5. And just to make sure, yeah, that middle digit is either 4 or greater. Yeah. Sum is either 6 or greater. Yeah, sum is 6. And it has no pairs. Well, let's give that a try. Okay, so what can we test again? Well, the whole premise of this was that the sum is 6. So let's go ahead and test criteria card D again. Okay, yes, so the sum is 6. So that's fantastic. So let's go ahead and cross out the OR. Okay, and because the sum has to be 6, that means that triangle cannot be 3 or greater, because again, the only thing that makes triangle and square equal to 6 is 4 for square, 2 for triangle, 5 for square, 1 for triangle. So everything larger can be crossed out. Okay, let's see what else. And again, we still have circle outstanding. So if, yeah, it would almost be like square can't be the largest, because how would you pick between 1 and 2? Say there are no 3s, but I don't think we can assume that there are no 3s. Trying to see if there are any ambiguous solutions. So 2, 4, if it were 2, 4, obviously circle could be larger. There'd have to be unique solutions, so it could be 1 or 3. So 2, 4, 1 or 3, depending on if there is a 3. And that's if square is larger. You can distinguish between them. What about 1 and 5? Well, maybe 1 and 5 cannot. Maybe 1 and 5 cannot be a possibility because, yeah, that would mean that square is automatically the biggest. But again, you still do have that criteria card B that you could have it be 3. So 2, 4. Yeah, it seems like there's still too many possibilities. So let's see. Can we tell if we test the largest? Again, it's going to be between square and circle. Yeah, let's go ahead and do the largest and see where that takes us. Okay, so it is not true that circle is the largest. Very interesting. Okay, so yeah, so my circle is the largest, but that is incorrect. Obviously, it doesn't make sense that triangle would be the largest. So let's type it up as we're going to deduce that square is the largest. So let's go ahead and type that up. So we'll say square is the largest digit. Okay. So did that help us out? We still haven't definitively. Let's see. So if 4 is the value, that would make triangle 2. And then the only viable solution would be 2, 4, 3. Because how would you distinguish between 1 and 2 if there is no 3? There is no way. So it would have to be 2, 4, 3. And I believe that to be the case. The only case if square is 4. 2, 4 has to be 3. Let me go ahead and type it up just all the same. So 2, 4, 3. And again, that's the only case if square is 4. Okay, what if it's 5? Then it would be 1, 5. And then here, again, there are way too many possibilities, right? How would you distinguish between 1, 2, 3, and 4? Well, the only way is if there is a 3. So it looks like it may be safe to deduce that there is a single 3. So I guess the test that we have to do is A again. Is it a 4 or is it a 5? That looks to be the case. 2, 4, 3, 1, 5. Well, yeah, if it's 1, 5, it means everything is smaller. Remember, we can't have duplicates. 1, 5. If there is no 3, yeah, how would you pick between 1, 2, and 4? Yeah, I'm pretty sure we can deduce that there has to be a 3. So yeah, let's go ahead and test criteria card A. That seems to be the deciding factor. Okay, yes, it is true that square has to be equal to 4. So let's go ahead and update our notes here. And it is a 4, so that means square cannot be a 5. And it forces triangle to be a 2. And we know that square is the largest, so that means circle cannot be either 4 or 5. Circle has to be smaller. You can't pick between 1 and 2. There's no way to distinguish those two. Those would be ambiguous solutions. So it looks like, yeah, it's safe to deduce that there has to be a single 3. So we'll say here, deduce the solution has a single 3-digit. Okay, so yeah, it looks like our solution should be 243. So let's go ahead and type that up. And let's just verify. Well, let's actually cross out the 153 here. And just quickly verify. Yeah, we determined that square should be 4. Yep, square is 4. We deduce that there should be a single 3. There is. We did deduce C that it should be the largest, since circle failed to be the largest. Yeah, that would default square to be the largest. It is. The sum of the first two is 6. It is. And there are no pairs. Yeah, so that looks like our solution. But let's go verify. 243. 243. No. Oh, wow. 243 is not correct. Okay, so the sum does have to be 6. So that is correct. I can't see how triangle and square could be anything else but 2 and 4. We confirmed A, that square is 4, forcing triangle to be 2. We deduce that there is a single 3. Since square is the largest, circle cannot be the largest. It failed. Circle can't be the largest, so it has to be square. Okay, so 4 is bigger, so it can't be 4 or 5 because you don't have pairs. Okay, so it looks like there is no 3. So how do you pick between 1 and 2 for circle? I have no idea. Something is very wrong here. Yeah, there has to be, it can't be a triple digit because there is a largest. So they all have to be distinct. What is going on? Yeah, square is 4. That forces, and the sum is 6. 2, 4. Circle can't be 5. It's not the largest. So circle can't be 4 because, again, it's got to be smaller than 4. So it's between 1, 2, and 3. Oh, wait. Oh, I see. Okay, so if that were the case, okay, yes, you can cross out 4 and 5. You can cross out the 2, but perhaps, there it is. There is no 3. Okay. So, yeah, so we're going to test it one more time, and we're going to say it's going to be 241. 241. And let's test B. I didn't see that. I did not see that. So yeah, let's do B. And it should be true that there is no 3. Yeah. Okay. So let's go ahead and cross out this solution here and the solution should be 241. Okay, and let's update our notes here. Let's see, well, we'll say that there should be, the solution has no, and I'll just cross this out. Oops. No 3-digit. Okay. Yeah. So let's cross this out as well. Yeah. So obviously it's a lost cause since I did get it wrong. Solution does seem to be 241. We'll verify in a second. But yeah, that was the way you would distinguish between 1 and 3, is that there is no 3-digit. Oh well, okay, it will happen. So let's go verify 241. And there we go. Okay, well, let's go see how the Turing machine did. Because, yeah, here basically it did take me 7 turns. And I'm trying to think. Yeah, that would have been normal gameplay anyway. So let's see. So we did ADE in the first round. And then we did ACD. Okay, so ADE and ACD. Let's see if I can remember that. ADE, ACD. ADE and ACD. Ooh, I think A was correct. I think C was incorrect and D was correct. And then we did B and got it correct. Yeah, we would have tied. We would have tied with the Turing machine had I not overlooked or dismissed, I guess, the fact that we would have been left with 1 and 3. Not sure. Yeah, I think I just got tunnel vision on the fact that I couldn't distinguish, but I really didn't give a 1 for circle its fair share of attention. So I just totally dismissed it, and I shouldn't have. Okay, well, that does it for this video. How did you solve it? Hopefully you didn't make the same mistake I did, but did you choose a different set of criteria cards that helped you find the solution more efficiently? Please share with that information in the comments section. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.